Okay, good evening all. So hope my voice is audible to everyone. Is it audible, guys? Can you all quickly respond on chat box? So once my voice is audible, and what about my screen? Can you confirm? So is my screen visible to everyone? Okay, thank you all, guys. So now the time is exactly 5:50. So good evening once again. Let's take a moment to reorient ourselves. Guys, actually, last class we have completed a very thorough discussion on the core concept of big data. Okay, we started with motivation and moved into data classification and the problems with traditional systems and concluded with the key characteristics that define big data system. Okay, so in today's session, so we can see from our roadmap on the screen, so that I will show you later. So it is a time to shift gears, guys. So we are moving from the what and why to the how. Okay, let me share my screen. Okay, so as I told, so we have completed with discussion part. We have completed with what is big data system. So under that, we have learned characteristics, design challenges, everything. Okay, now, so as I told guys, so we are moving to how. So we are moving to how part. Okay, so our major topic is architecture. And this is where we will start to put all the pieces together. And we are going to answer questions like, uh, so what does a typical high-level architecture of big data solutions look like? And what are the different components that make up the technology ecosystem? And how do different companies use these architecture in case studies? So these are the three topics we have included in architecture part. And after that, so we'll jump to locality of reference and storage organizations. And finally, we are going to conclude this session by what? Summarizing the entire first session concept. Still, I am not done with the first session concept, guys. So you all know, right? I'm going very slow and I'm taking too much of time to explain each and every concept. So that's why I'm not yet completed first session concept still. So yes, once I complete this, so second session onwards. So let me take 20 minutes extra class. Otherwise, we can take extra class to complete one session concept. Okay. So, but I don't want to compromise with what? Teaching fast. Okay. Yes, guys. Yes. Now we are moving into the very next slide. So you can observe here. Guys, already we have talked about data, the problems, and the characteristics of the systems that solve them. Okay. Now let's look at the what final piece of our puzzle for today. So what are the different types of problems, or what are the different types of solutions? Correct? No, that big data architecture are designed to handle. So it is just one thing, guys. Okay. So there are three major paradigm. Okay. Three major paradigm. So one is called as batch processing. So this is the first one. Second one is called as real-time processing of big data in motion. And third one is interactive exploration with ad hoc queries. So these are the three paradigms. So we are going to learn with respect to processing data. Okay. So what is the first one? So you can see here. First one is batch processing of big data sources at rest. Guys, this is the most traditional type of big data processing. Okay, the name says it all. Correct? Now we are processing a large batch of data that is at rest. Okay, the meaning of this is it has already been collected and stored. That's it. That is the meaning of this, guys. That's it. Very simple. So think of it as a what huge warehouse full of data. So we don't need the what results immediately. We run a long, complex job that might take minutes or even hours to complete. So this is the what perfect case use case for machine learning concept. Okay, so building machine learning model and statistic aggregation. So for this, it is well suited one. See, for example, we might analyze a year's worth of historical sales data that train a machine learning model. So for that purpose, we are going to use this. And look at the question given here, guys. What percentage of users in US last year watched shows starring Kevin Spacey and completed a season within 4 weeks or a movie within 4 hours? Okay, or we can say it in different fashion, guys. Predict number of US family users in age 30 to 40. So who will buy a Kellogg's cereal if they purchase milk? See, these are the questions that require a lot of data. Okay, and a bit of delay in getting the answer is totally fine. Okay, so and next we are moving into the second part of the paradigm that is called as real-time processing of big data in motion. Guys, this is just opposite of big data, batch processing. Okay, here we are dealing with a constant stream of data in motion. Data in motion. So we need to process this data with very low latency. So that is often in milliseconds, guys. So many times we are going to complete the execution of this data in milliseconds. Understanding my point? The value of this data is highest right at the moment it is generated. Okay, so this is the domain of what, guys? This is the domain of fraud detections from real-time financial transaction data. And also this is the domain of detect fake news on social media platform. So anything I can take as an example, guys. So let me take one example. So let me take the second one, detect fake news on a social media platform. Guys, so we need to analyze posts as they are made and quickly flag or remove content that is spreading misinformation. Okay, the faster we can do this, the better. Correct? No? That is what exactly I'm saying, right? This is the main intention of what? Detecting fake news, and immediately we have to what? Remove it. So that has to be what happen in real time. And what is the third one, guys? The third one is called as interactive exploration with ad hoc queries. See, this is for the business analyst and this is for the data scientist. So we want to ask spontaneous open-ended questions of the data. Okay, they don't want to wait for a batch job to run, and they are not looking at a what real-time stream. They want to be able to query the data and get an answer back in seconds or back in few minutes. Understanding my point, guys? And also we have given one example, which region and which product has least sales growth in last quarter. So this is the perfect illustration, right? So this is a question a manager might ask in a meeting, and they would want to get the answers quickly. Okay, so these are the what 3 different types of solutions we are going to, guys. The important thing to understand is that a complete big data architecture often needs to support all 3 of these types of solution simultaneously. And you might be what running a daily batch job to train a machine learning model, while at the same time running a what real-time system to detect fraud, all while a data analyst is running an ad hoc query. So everything has to happen in a what single architecture. Okay, so let me show you the diagrammatic representation. You all can see the diagrammatic representation here, right? Look at the diagrammatic representation. So what and all we have included here? Guys, this is the big data architecture style that is designed to handle the injection, processing, Okay, and analysis of data that is too large or complex for traditional systems. Okay, so think this as a what? Complete blueprint. Okay, regardless of the specific technology it uses. So we'll have what components that fits into these boxes. Okay, so let's walk through it, guys. So what is the first one? This is where it all begins, right? That is called as data sources. So remember our earlier example. So this is all that chaotic, so wonderful data we talked about. Okay, a millions of clicks from the what online retailer, the sensor data from the what jet engine, a social media post, everything. So everything is called as what data sources, is it? So and notice here, guys, notice here. So data flow split into two main paths. See here. Here we have separate path and here we have another separate path. So this is where we handle the difference between data in motion and data at rest. Okay, so which one is at rest? So this is at rest, right? See, this is data in motion. Are you getting my point, guys? See, the top path is for our real-time data. So this is for the what? Real-time data. So that is about what? Real-time fraud detection. Okay, that data comes in and goes straight into real-time message injection. This is another layer. And what do you think this layer is? Exactly, it is our queue. Okay, so we saw how a queue acts as an intermediate layer in the previous one, correct? No? So buffering the incoming data here. Okay, so from there it goes to stream processing. So where a dedicated engine processes the data on the fly. Okay, so this is where we would have our logic to instantly flag a fraudulent transaction. And next to that, what do we have, guys? See, now let's look at the what next one. So this is for batch, right? So this is the what bottom one. This is the top one. So this is for our batch processing. Okay, the data goes into the centralized data storage. This is centralized one. And this is our low cost, long-term storage solution that we talked about. So often a distributed file system. Okay. So this is and this is where we keep all the data at rest. So when we want to do some complex analysis, so we run batch processing. Okay, we run batch processing job against all stored data. And this is where we would train a machine learning model to predict what a consumer or customer will buy next. Are you getting my point, guys? See, after completion of these two, the data has been processed. So whether in a real time or in a batch, so it often gets stored in a analytical data store. So this is the database, guys. This is the database. Okay, this is the database optimized for fast queries. So our business analysts don't have to wait for hours to get a report. Okay, so finally, all this leads to the what? Analytics and reporting layer. Analytics and reporting layer. So which is where the value is delivered. So delivered in the form of what, guys? Delivered in the form of dashboard. Delivered in the form of report. Okay, so delivered in the form of insights. Okay, these outputs are drive the what? Business decisions. Understanding my point, guys? This is the flow, guys. This is the flow you have to understand clearly. And see, we have one more layer here that is called as orchestration. Okay, this is the bottom layer. So we have in this architecture. So this is the what? Conductor of our orchestra. Okay, so it manages the entire workflow. Understanding my point, guys? from data injections to processing to reporting. So it makes sure everything runs on time and it handles failures if a process crashes. So without it, the whole system would fall apart. So hope this diagram is crystal clear to everyone. So if you have any question to ask now, you can ask me, guys. Till here, everything is clear. Yeah, I've started with recording. The recording is started. So till here, everything is clear. So do you have any question on architecture? Does this high level architecture make sense to everyone, guys? Can I get quick responses and chat box? Guys, this is the fundamental model for the rest of our course. Okay, I have displayed fundamental model. That's it. Okay, thank you all, guys. Can you explain once batch? Okay. See, look at here. Batch is very easiest one. See here, the data at rest will go to this data storage. So data storage means, so this is the best example for your warehouse. See, data is stored. So I can store data for a longer time here. So after that, for processing, we are going to use batch processing methodology. So after batch processing methodology, so we are going to get some data for an analysis. Correct now? That data we are going to store inside analytical data store. Even we are going to store real-time data inside the analytical data store. So after storing any type of data, so whether it is from batch processing or from stream processing, so later on we are going to perform analysis. This is simple one. Okay, hope am I cleared his doubt. Okay, where is that, guys? Okay, it is here. Sir, could you please explain the difference between the data storage and analytical storage? See, in data storage, see, this is very simple, guys. I don't know why you people are getting this doubt. Guys, data storage, so this is for static data. This data storage is for real-time data. So this is for real-time data. Real-time data means we'll be getting what data continuously. So here what we have to maintain, guys, we have to maintain queue. So inside this, we have to maintain queue. Last class, I have shown you this, right? So we are going to store data in the form of queue here. So based on this, you will get data into the what? Streaming processing. But here we are going to store data in the form of what? Traditional storage system. Okay. So simply we are going to store the data here. That's it, guys. That is the difference. That is a small difference between these two. Is this clear? Data storage for raw data and analytic data storage for process data. Yes, exactly correct. Guys, everything is clear. Stream processing means you will be continuously getting the data. See, suppose you are getting continuous data means then you have to use Spark kind of tool to execute or process the real-time data. But not in the case of batch file, guys. Batch file, you can use machine learning. So machine learning is enough. But in case of stream of data you are getting means then you have to use Spark. So hope Joshi, I have cleared your doubt. There we are going to use different tool. So here we are going to use different tool. Clear? Guys, in future you are going to what? Elaborate on the same thing, guys. No need to worry now. Now you look at here, guys. Same thing I'm explaining you again and again. Don't get confused. Otherwise, don't get bored. Guys, we are start filling in some of these generic boxes. So we just saw in our what high level architecture diagram. So this slide gives us a glimpse into some of the what real world technologies that make up the what big data system. Okay, what is the first one? The very first one is data sources. See, this is the first part of any system is where the data comes from. Okay, see the diagram on the right hand side, you can see. So we are getting data from different resources. So we are getting data from media, cloud, web, IoT, databases, social media, social influencers, okay, activities generated data. See, we are getting data from different resources and variety of data we are getting to this data resources. And what is the second one? Second one, already I've told you about data storage, right? So what is data storage? So this is the what heart of our system, is it? So when we talked about batch processing, we mentioned that data is processed at rest. Well, so this is where the data rests actually. Okay, it is not a single database server anymore, guys. So it is a distributed one. Try to remember this. So it is not a single one. So it is a distributed file storage. Okay, that holds massive volumes of large files in various format. Okay, so next we have, look at here. Next we have talked about what? See, and also here you can observe. I have mentioned few tools here. I have mentioned Cassandra. I have mentioned Hadoop HDFS. See, all these tools you are going to use in future. Okay, so what is the first one? I have talked about Cassandra, right? So Cassandra is a what? NoSQL database system. Okay, so it is not traditional RDBMS, guys. So this is a what? Modern NoSQL database. And it is designed to be what? Distributed and highly scalable and making it perfect for storing write-heavy semi-structured data. That I will explain you later. No need to worry now, right now. And what about the second tool I have mentioned here? I have mentioned Hadoop HDFS, right? Guys, HDFS stands for Hadoop Distributed File System. So this is the what technology that provides at low cost, fault tolerant storage. So we were talking about. Okay, it is perfect for storing massive files. So like the raw data from sensors, web logs, even from medical images. So everything we can store inside HDFS. It stores these huge files across a cluster of commodity hardware and making it incredibly cost effective and reliable. So hope this is crystal clear to everyone. And nextly, so we are talking about what? Batch processing system. You can observe here. Okay, so we already defined this as what? Processing a large batch of data at rest, right? So, but what does that actually look like? Guys, the diagram on the left-hand side, you can observe here. The diagram on the left-hand side, so gives us visual representations of the core idea behind Hadoop MapReduce. Try to understand this. So I'm explaining you now Hadoop MapReduce system. So this is one of the what? Foundational batch processing framework. So even in your lab session, you are going to work on this, guys. So the data is first broken down into smaller chunks. Look at here. So this is the data we have taken. Okay, the color blue, bluebird, the blue sea, flying bird. See, we are dividing this data into smaller chunks. Okay, so after that, what do we have here? Map task. So the main task of this map is to split data into different chunks. See, da is stored somewhere, color is stored somewhere, blue is stored somewhere, and bluebird, again blue here, bird here. And along with that, I have taken 1 year. See, I have stored data in the form of key value pair. So this is stored in the form of what? Key value. So initially key I have taken as what? Each word of your data. And 1 is nothing but a value. This is the initial value I have taken here. So initially I have taken this as 1. So hope this is clear to everyone. Same thing I've done with all. The blue sea. Look at here. 1, 1, 1 is assigned here. And flying bird, 1, 1 is assigned here. See, here we have splitted the given data into different chunks. See, after completion of this, so what we are doing in this step, guys? What we are doing in third step? What we are doing here, guys? See, after mapping is done. So after that, so we are collecting similar words together. Look at here. So here we have one the, and here also we have one the. So both I have stored here. So it is a kind of sorting. It is a kind of what? Sorting actually, or shuffling, whatever you call. And color, we have only one word, so I have put separately. Next, blue, blue, blue. We have 3 keywords here, correct? No? So here we have one blue, here we have another blue. So here we have one more blue. So all three blues I have kept here. Next C, flying, bird, bird. Correct, no? After that, we have one more model here. What is that? That is reduce model. What reduce model is going to do? So it is going to check with this word. This word and this word both are same as, then it is going to add these two values. Look at here. This is also the, this is also the, right? Then I have to add these two. So then what it will become? It will become 2. See, that is the job of reducer. So reducer is reducing the occurrence of the. So what is the occurrence of the here, guys? That is 2, right? And what is the occurrence of color? 1. What is the occurrence of blue? 3. What is the occurrence of flying? Again 1. What is the occurrence of blue? 2 again. What is the occurrence of C? 1. See, these are all. So here I have not mentioned reduce for this, but yes, guys, it is going to what? Combine all the data, and finally it is going to give word count. Finally, it is going to give word count. See, this is the sentence or file we have taken in 2 different databases. So finally, it is going to check the occurrence of each word. See, this is with the help of what? Map and reduce algorithm. This mapper and reducer algorithm is best suited for batch processing. Understanding my point, guys? So hope this is clear to everyone. Let me check whether you have any question on this or not. So we have a separate model on this, guys. I will explain you later. Okay, once I am moving into what big data concept, so I am going to teach you how to write a program for map reduce by using Python and how we are going to execute it. So we will take one real-time example. Okay, one text file we will take and we will work with word count programming. No need to worry about that. So have you understood? So batch process is going to use what, guys? Batch process is going to use map reduce concept. That is what you have to understand, guys. That's it. Okay, sir, is HDFS only solution for DFS or there are other tools as well? No, HDFS is suitable for DFS. Okay, distributed file system. Guys, so once you are storing data in HDFS, what HDFS will do? So it will automatically distribute data in our different system by default. Okay, here there is no involvement of programmer, guys. So there is no involvement of any administrator. So once you are pushing data into HDFS, you just imagine. So in your big data ecosystem, you have 5 different systems. Okay, 5 different clusters. So once you are pushing your data into HDFS, it is the job of HDFS. It will push all the data. It will distribute all the data into different clusters. That is the beauty of using big data tools actually. So this big reduce has performance overhead for splitting. Yes, of course, yes, Ravi Kumar. But yes, we are talking about the computation of huge amount of data, right? So then splitting overhead is negligible. Correct, no, Ravi Kumar? Sir, it is grouping value or occurrences of the data. That is based on the program we have written. See, in my program, I'm trying to what? Counting the number of words. So that's why it is grouping the value or occurrence of the data. Okay, suppose you just imagine you are finding the employee who is getting more than 10,000. See, there is a what variations, right? Then we are not going to count the number of occurrences. So instead of that, we will calculate something that is based on the problem statement. So in my problem statement, I've taken word count. That's why I've taken what occurrences of the data. That's it. So is this clear to everyone? So any doubts? Any doubts with respect to what map reduce concept? No, right? Okay, fine. So then I will move to the next slide. Look at here, guys. Next, I'm talking about real-time message injection. Guys, here, this is the what other half of our processing model. So this is for the what data that needs to be what processed in motion with very low latency. Okay, so it is about capturing data from real-time sources and feeding it into a stream processing engine. Are you getting my point, guys? A great example of a tool that does this is Apache Flume. See, here it is clearly given. Apache Flume is the Best example for this, guys. So Flume is designed to collect, aggregate, and move large amount of log data from various sources to the centralized data store. Guys, you have to install only Flume, that's it. So the job of Flume is, so it will collect the data, it will aggregate the data, and move that large amount of data from the what? Various resources to the centralized system. Okay, this is for real-time data set, guys. You have to what? Remember this. So look at this example, credit card transaction for fraud detection. Okay, so here, so this Flume will play a what? Crucial role. So hope this is clear to everyone. Guys, here, see, so we have two more critical components of big data system. One is batch processing for our long running and the deep analysis like your Hadoop, and real message injections for our fast moving data. So the best example for that is Flume. Flume is the best example. So example for this is Hadoop. Example for this is Flume. Is this clear? Okay, now look at here, guys. Already I've told you about this, right? So this slide already I've explained you, right? Stream processing. Suppose, see, you are continuously getting data. See, you're continuously getting data and you have to execute that data. Otherwise, you have to calculate that data or aggregate that data very fastly. Means then you have to store that data inside the what? Memory. So that's why stream processing. See, the example for this I've taken as Spark. Spark is best example for in-memory filtering. The meaning of this is, see, you just imagine you have a computer system. So inside computer system, we will be having separate RAM, right? So here also, see, this is the cluster. Let me take this as a cluster. This cluster is containing 3 systems. So each system is containing RAM here. Here also we have RAM, here also we have RAM, here also we have RAM. We have RAM, right? So here, all these data, instead of storing data inside hard disk, it is going to store data in RAM. So that's why the concept is called as in-memory. So that is possible in case of Spark. So here, once you are getting real-time data, all the data are going to store inside this Spark for processing purpose. And it is also going to what? Process data in the form of what? Distributed format, and finally it is going to give a correct answer. Clear my point, guys? And what is the last one? Last one is called as analytical data store. See, for analysis, see here I've shown you, right? So here what you have to do, guys, you have to perform analysis. See, to perform analysis, you can create your dashboard. So to create your dashboard, you can use Tableau. So to create your dashboard, you can use Power BI. To create your dashboard, you can use Python with what? Some inbuilt inbuilt libraries. Okay, and you can create report, you can create insight. So everything is possible with the help of all these tools actually. By using MongoDB, I can achieve this. By using HBase, I can perform queries. By using Hive, I can perform queries. As I told, by using Tableau, by using Power BI, so we can create a reports, we can create a dashboard. So everything possible in case of what? Analytical data storage. Okay, these are all analytical data storage, guys. Okay, so this is not, see, this is not creating any report. So we are creating report in the form of, in what? Last phase. But here, what I would like to say is, so we have to store that data, right? Where we have to store the data? So we can store the data in a MongoDB. We can store the data in a HBase. We can store the data in a Hive. See, this HBase and Hive, it is like a what? SQL query. By using SQL queries, so we can perform any of the what? Any of the what game with respect to your HBase and also Hive. Are you getting my point, guys? And finally, we have Tableau. And as I told, so we have so many things, so many tools to generate your report, and orchestration and ETL. So the best example for that is Oozie. Okay, most big data solution consisting of what? Repeated data processing operations, encapsulated in workflow, transform data source. See, for each and everything, the best tool is Oozie. So by using Oozie, so I can perform the job of what? Orchestration. So this orchestration is a kind of what monitoring thing, guys. Are you getting my point? It is a kind of monitoring. That's it. Are you getting my point, guys? See, this is the most critical component that ties everything together. Remember that horizontal orchestration. So I've shown you in the architecture, right? Okay, so most big data solution consist of repeated data processing operations, workflow that transform source data and move in between different systems. To automate these complex workflow, we use an orchestration technology. Okay, it is a great example of an open source orchestration tool that is called as Uzi. So which is specifically designed to manage and schedule jobs in Hadoop cluster. Guys, other examples we have Azure Data Factory we can use here. Otherwise, we can use Scoop also. Scoop is also one of the best example. Okay, our Azure Data Factory also best example for this orchestration. So hope I have given you enough information to understand the architecture of big data. So is this clear? What is OLAP? You have to tell me, guys. What is OLAP? What is OLAP, guys? Can anyone tell me? What is the abbreviation of OLAP? These can be various OLAP. Yes, what is OLAP, guys? Online analytical processing. That's it. So architecture is crystal clear to everyone, guys. Architecture is crystal clear to everyone, guys. See, we started with the raw data from our data sources, and we decided to handle our real-time data with the tools like Apache Flume, Spark, and our historical data with Hadoop HDFS, MapReduce. And the process data then ends up in a store like Hive, HBase. So where we can analyzed using tools like Tableau. See, guys, all this managed by orchestrations tool like Apache Uzi. That is the entire concept. So we have discussed till now. Okay, so I think now you people are getting little bit idea. So how to store data in a different layers. Okay, what and all tools are beneficial in a different layers. So is this clear to everyone? Is this crystal clear to everyone? Shall I get CC and chat box? Okay, fine. Next, guys, now look at here. So now look at here, guys, everyone. This slide is a comprehensive, if a bit dense, so overview of how all these components fit together in a real world ecosystem. So showing mostly Apache project. Okay, you can observe now. So what and all is there here? So let me start from the bottom. So this is the bottom layer. So we are using layered approach here, guys. So at the bottom for storage, we are all using HDFS. So this is our low cost, long-term distributed file system where all the raw data lives. Clear? That is the first layer. And next to that, we have resource management and basic MapReduce or Yarn for Hadoop nodes. So this is the layer that manages all the different servers in the cluster and runs our fundamental MapReduce job. Understanding my point, guys? And next to that, what do we have? So look at each vertical column. So each of these represent a different functional component of our architecture. And you can see a variety of tools within each one. Correct? No. So in the in-memory processing, we are using Spark. So for stream processing, we are using Storm, Kafka, and Sparkus. And for SQL over Hadoop means we can use Hive. For NoSQL, we can use HBase and MongoDB. So SQL means it is a structured data. Suppose you have a structured kind of huge amount of data means, then go with Hive. Okay, suppose you have unstructured data, otherwise semi-structured data means, then you go with HBase and MongoDB. Okay, suppose you are searching something, then go for Solar, SOLR. In short form, it is called as SOLR. And ETL, you have Flume, you have Scoop, and machine learning means you have a separate library here with respect to Spark, that is called as Spark ML lib. And scripting means you have Pig and scheduler. So we have a scheduler, separate scheduler here. The scheduler, or we can call it as orchestration. So that is called as Uzi. So hope this is clear to everyone. And this is for monitoring, coordination. For coordination, we are using Zookeeper. See, look at here, guys. We have mentioned different tools here. We have started with HDFS and next MapReduce, Zookeeper, Spark, Hive, Pig. And we're talking about Spark ML lib. And we are talking about Hive. And we are talking about Solar, MongoDB, HBase. See, so many tools I have introduced here, right? See, so many tools we have fit inside single architecture. So hope this is clear to everyone. So don't ask me any question on this, guys. So you have seen right in your handout. So we have 10 different programs. See, we are trying to cover all the tools in the 10 different programs. So I am going to show you how these programs, so how these tools are useful. So when we are running our data, that I will show you later, guys. No need to worry now. So the diagram is crystal clear. Shall we take one case study? Actually, we have listed 2 case study. I'm not going to explain 2. I'm going to explain 1. So is this clear to everyone? Shall we go with case study quickly without wasting time? Shall we go with case study, guys? Guys, I want you people to respond quickly, guys. I don't know what you people are doing. Huh? Thank you all, guys. Okay, so the very first case study I've taken as Netflix. Guys, so the goal here is to understand how a company like Netflix uses big data to achieve exponential user growth and retention. That is already I've mentioned here. And this is a source from where I've taken all these informations. Okay, even I have mentioned reference also. And look at here, guys. Think about the data Netflix collects. So what data it will collect, guys? Can anyone tell me quickly? What data it will collect, Netflix? It is going to collect a massive amount of data, right? See, it is about millions of transactions. So browse clicks every day. It is a data about which movie and shows, which movie you have watched and for how long you have watched and when you passed and when you fast forwarded. So, and it is going to collect the reviews. It is going to collect the ratings from you people. Correct, no? So this is the perfect example of a data driven enterprises. Am I right or wrong, guys? They use this data to do things like user profiling. So that will give you better shopping experiences and demand forecasting. Okay, that is going to decide what new shows to produce, and improving customer support by analyzing support emails and also logged calls, and most importantly for product marketing. Are you getting my point? So Netflix success is a testament to the idea that data is the only way to create competitive differentiators that retains customers and also ensure growth. So as we go through this case study, I want you to think about all the concept. So we have covered. So think about what types of data, challenges of storing it, And the architecture, they would need to be what build system that can make real-time recommendations and huge batch jobs to predict what shows to produce and allow a data analyst to query viewing habits. Okay, so this is the bridge between theory and practice, guys. Okay, and it is where things get really interesting. Am I right or wrong, guys? Am I right or wrong? Yes, no? Now look at here. So here, what I've taken, see all the information what I've mentioned. So I have put in a what single slide. Correct, no? See, this is showing 150 plus millions users data. Okay. So it is listed what? What is the data it is listed? A number of data points it is listed. And as you read through them, you will see a mix of all the data types we have discussed. So Netflix is collecting a massive amount of data from over 150 million users. Okay, so let's break it down, guys. The very first one is date. So date, content watched. What is the second one? The device on which the content was watched. Guys, was it on your TV? Was it on your mobile phone? Or was it on your laptop? All the information is going to collect, guys. This is also structured data that is crucial for understanding users' habit. Okay, and what is the next one? How the nature of content watched varied based on the devices. That is the third one. So this is a what more complex analysis. Am I right or wrong, guys? This is very complex analysis. For example, do you watch longer movies on a TV and shorter shows on your phone? Are you getting my point? And what it is going to do next? Searches on its platform. So every search you perform is logged. So this is the valuable for understanding what you are looking for, even if you don't watch it. Correct? No. And next one, portions of content that got rewatched. So did you watch the same scene over and over? That is the huge signal of engagement and something Netflix pays attention to. And whether the content was passed. So this tells them about your viewing behavior and can indicate when you get distracted. Correct? No? And what about next one? User location data. Where in the world are you watching from? So this is essential for things like content licensing and regional recommendations. Okay. And time of the day. So time of the day and week in which content was watched and how it influences the kind of content watched. Are you more likely to watch a comedy late at night? So this is the key data point for their recommendation engine, right? And one more, we have metadata. Metadata from third parties like Nielsen. So they also integrate with other data sources to get a more complete picture of viewing habits. Correct? No. And finally, we have social media data from Facebook and Twitter. So this is the great example of bringing in unstructured data to understand what people are saying about their shows in a real time. Guys, as you can see here, this is a massive volume of data. So coming in at high velocity and with a huge variety of formats. Okay, so it is a perfect storm of big data. Okay, a traditional system would choke trying to handle this much data, and a lot of this data, especially the social media data, is semi-structured or unstructured. So this is exactly why a system like Netflix needs a robust big data architecture. Okay, so next we have, look at here, recommendation system. So these are all the recommendation systems I have mentioned here. Correct? No. This is the secret sauce behind their success. So personalized context ranking. Okay, their system does not just show you top 10 most popular shows. It shows you what is mostly like to be relevant to you. So based on your past viewing history, the time of the day and device you are on, and content promotion influenced by personal interest, and intelligent prioritization of viewing content that users are expected to watch or rewatch, and what type of content is likely to be what popular to decide new shows. This is very, very important, right? This is where big data moves from simply making recommendations to making multi-million-dollar business decision. Okay, so the great example for this is the show, The House of Cards. Okay, so Netflix contracted for 2 seasons of the show without even filming a pilot. Why? Because their analysis of historical viewership data across regions for past content by cast and crew said that show would be popular. This is the power of big data in action. Okay, so it is just a guess, guys. So it is about data-driven decision. So this is the perfect example of how a data-driven enterprise uses technology to drive competitive differentiators, retain customers, and ensure growth. Correct? No? Netflix business model is fundamentally built on its ability to leverage its massive data sets to make these kinds of decisions. Okay. Guys, we have now seen the what and why, right? We have seen the data they collect and we have seen how they use it. What is the obvious next question, guys? What technology do they use to make all of this possible? That is the question we have to answer, right? Look at here. Look at the example. So here we have mentioned all the technology required for this Netflix. The very first one, they are using Amazon S03 for storage. Okay. And resource management, they are using Hadoop. So yeah, this is the basic model, inbuilt model they are using. They're not using any extra models here. So they are using Hadoop nodes. And it is a kind of structured data. Since it is a kind of structured data, they are using Hive. So Hive to store their data and perform some queries. And for ETL, for management completely, they are using Pig. And for scripting also, they are using Pig. Guys, you have to remember this. Suppose tomorrow you are targeting Netflix means. You are aware of this Amazon S3, you are aware of Hadoop, you are aware of Hive, Pig means it is enough. Okay. So this is one of the real world example of how a company like Netflix might use the technologies we have been talking about. Is it interesting? So how many of them are feeling this is interesting? Is this a good example to explain the concept, guys? See, Netflix is the one example I've taken for you people, guys. You take one more example. Suppose you want to take YouTube means you take YouTube and you search on that. So what exactly they are doing? So you have to do some literature survey. That's it. So once you are doing literature survey, then it is very easy to understand, guys. That very simple. Okay, another case study I've taken here, that is IT operations. So I'm giving you this as homework problem for you people. Okay, I have given all the informations here. You just go through this, and even I have given the complete architecture for this, but I'm giving you this as your homework problem. You have to analyze by your own. That's it. So is this clear? Is this clear to everyone? Till here, do you have any questions to ask? This is how it is taking too much of time to complete the syllabus, guys. So now the time is already 1 hour. See, within 1 hour, I have explained only 7 to 8 slides. That's it. Okay, maximum I've covered 10 slides. That's it. See how I'm going to complete the syllabus. Where to submit the homework? I have told you, right, Rajasukanya. So you can use your discussion forum. So once you are putting anything on discussion forum, so it will be helpful to your friends also. So even I'm going to see the solution of you people there. Okay, go to Texila. In Texila, you have a discussion forum and you submit your homework there. So let me see how many of them are going to submit the homework. Shall we move to the next part of your concept, guys? That is locality of reference. No questions means I will move to the next concept quickly without wasting time. Now, just now I've shown you, right, the format. What is the data you're collecting? The same format you can mention there. Otherwise, any format is okay for me. But finally, you have to come out with architecture. That is very, very important. You take the example of YouTube. And for that also, you can write your own what format. Clear? Guys, how many of you learned operating system concept? How many of you learned computer organization concept, computer organization and architecture? Computer organization and architecture. So once you have learned, means you type me and chat box. So I have 65 students. How many of them learned about architecture, computer architecture, COA? I think you're all familiar with this concept, right? Then you are all familiar with this concept, is it? Locality of reference. I think you have learned locality of reference in your computer system organization. Am I right or wrong, guys? Okay. So now we are focusing on the next very important concept that is called as locality of reference. So this locality of reference is playing a crucial role in building architecture of any big data. So that's why we have included this concept in your first session. Okay. Guys, here we are diving into a core principle that underlies the performance of all these big data systems. We have talked about the challenges of latency issues in algorithm and data storage. So working with large data sets. Okay. The solution to this problem is concept called locality of reference, or in short form, we're going to call it as LOR. Okay, we're going to call it as LOR. Okay, here it is clearly mentioned. Locality of reference. Guys, this is the fundamental idea behind why these distributed systems are so fast. And it is a concept that will frame our discussions for the next part of the course. And we are going to explore what this means and why storage and data organizations are so critical to achieving high performance in a big data system. So let's dive in, guys. Let's dive in. See, look at here, guys. The very first slide I'm showing you here is the fundamental issue is that big data system needs to move large volume of data. This is the fundamental issue. So think about our example. See, browse and streaming content on Netflix are answering analytical queries on e-commerce transaction data in Amazon. So this involves shuffling huge amounts of data around a distributed cluster. So the sheer act of moving this data over a network is often the single biggest performance bottleneck. Correct, no? What this will leads to, guys? This leads to the core question we will be answering in this section. That is there a way to reduce latency of data request using locality of reference in the data and request origin? So in other words, how can we make sure that the data we need is as close as possible to the code that needs to process it? This is the another way of asking the same question. Guys, the concept of locality of reference is all about minimizing data movement. Understanding my point, guys? Minimizing data movement. So it is the key to achieving high performance and low latency on these massive distributed system. Okay. So just now we have talked about challenges, right? The same challenge we are going to face here. Now look at here. Look at the next slide. Let's see here. So we first need to understand the different level of storage, right? That is very, very important. Am I right or wrong, guys? So this helps us to understand why moving data is such a performance bottleneck. Am I right or wrong, guys? So what is the first one? Computational data is stored in a primary memory, aka memory. So this is our RAM, right? Primary memory, R actually. This is R, memory. So both are called as what? RAM, right? So this is the fastest level of storage, and it is where your computer stores the data that is actively working on. Accessing data here is nearly instantaneous. That we all know, right? Correct, no? And the second one is called as persistent data is stored in a secondary memory or inside the storage. Correct, no? So this is your hard disk. The second one is called as your hard disk or hard drive, or you can call it as SSD. So this is where data is stored for the longer term. So it is a slower to access than primary memory, but it is non-volatile in nature. So meaning of that is data store inside this will be staying for a longer time. So when you are going to switch off your computer, means it is a kind of permanent storage. Okay, with our example, the example for this is HDFS. HDFS is the hard disk of our system, where data is stored on commodity disk for a longer time with retention. So HDFS is the best example. And what is the third point? Remote data access from another computer, memory, or storage over a network. So this is the slowest level of all, guys. So this is when your program needs to get data from another machine in a cluster. So which involves sending request over the network. So this is the expensive operation we keep talking about. Okay, guys, the entire concept of locality of reference is centered around the idea of performing our computations in the first two levels of minimizing needs for the third one. Okay, so we want to bring the code to the data rather than moving the data over the network to the code. Okay, so this fundamental principle is what makes big data systems so fast and efficient. Okay, it is the key to understand, or this is the key to address the latency challenge we identified earlier. Okay, so look at the next slide I have mentioned here. Okay, this is a known concept I'm explaining to you all, guys. So look at the main memory reference. So look at the L1 cache reference. Everything. You just observe here. Okay, so what is main memory reference? So it is almost equals to 100 nanoseconds, right? This is incredibly fast. Compared to this, look at here, 0.5 nanosecond it is taking. So compared to RAM, this memory is very fast. Cache memory is very fast. And look at here, disk seek. So how much time it is taking, guys? Look at here. It is taking almost 1 crore nanoseconds, correct? No? 1 crore nanoseconds. Am I right or wrong, guys? Or we can call it as 10 million nanoseconds. See, suppose to read 1 MB sequential from disk, it takes 20 million nanoseconds. Look at here, it is clearly mentioned to read 1 MB sequentially from disk. So it will take 20 million nanoseconds. Okay, this is a massive difference, right? See, look at here. Suppose 1K data. See here, 1 MB data sequentially from memory means. So it is hardly taking 250,000 nanoseconds. But how much it is taking here? Look at the difference. So here it is very less. Cache, it is very less. But cache will be not having what? Higher capacity. Correct? No, cache will be not having higher capacity. Okay. And finally, look at the bottom. What is mentioned here? Send a packet CA. Sending packet from California to Netherlands and Netherlands to California. So it is about 150 million nanoseconds it is taking. So even a round trip within the same data center is 5 lakh nanoseconds. So which is still much slower than accessing local memory. See, this is the data I've collected from this reference, guys. You just go and see in this reference. So all the data they have mentioned clearly. Guys, this slide perfectly illustrates our core principle. Okay, the numbers make it crystal clear. So network access is incredibly expensive. That is what I'm trying to explaining you here. So in a distributed big data system with thousands of machines, if you have to move large amount of data over the network for every single computation, your system will grind to the heart. Okay, so this is the entire reason why we have to focus on locality of reference. So we want to design our systems and our algorithm to minimize this expensive data movement over the network and instead, so perform the computations on the machine where data already resides. So this is the fundamental concept that we will explore in more detail in next coming slides, guys. Okay, let me check if anybody of them have put question on the chat box or not. No questions, right? You all understood the purpose of using locality of reference. So once you have understood, please do type me understand on chat box or understood on chat box. So I will move to what further concept. Understood? Okay, fine. Now look at here, guys. This is another familiar diagram for you all people. Correct? No? See, now we have to wrap up on locality of reference. Let's visualize everything we have talked about. So this slide shows memory hierarchy. Okay. So which is the motivation behind why we care so much about where our data is located. Okay. So first look at the classic memory hierarchy. So this is the classic memory hierarchy. A processor needs data. So it first looks in the fastest, smallest store, that is called as your cache memory. If it is not there, so it looks in slightly larger, slightly slower RAM. So if it is still not there, so it has to go all the way to the disk. So which is slowest but largest storage. So the principle here is to use the hierarchy of fast, small memory and large, slow memory to amortize the cost of access. Okay. And now look at the modern memory system. Okay, memory hierarchy. So this is one that relevant for big data system. Okay. So we have extended that classic model to a distributed system. So we still have our fast local memory, but now we have network cache. See, we have introduced network cache here. So which is essentially a proxy for data on another machine. And at the end of the hierarchy, we have remote store. You can observe here. So we have remote store. So this remote store is our distributed file system like HDFS. So accessing this is the most expensive operation of all. So as we saw from our latency number. Okay. So the whole point of this modern architecture is to design our system so that we are always trying to get data from the fastest layers of this hierarchy and avoiding the slowest one. So this is why, so we have tools that keeps data in memory as much as possible. The cache frequently access data. The text box on this slide. Okay, look at here. So in this text box, I have mentioned something, right? Some information I have mentioned. In a big data search, recent solar indexed data can be cached for long-term HDFS data. So this is the perfect example of using faster store as a cache for data that is kept in this lower long-term HDFS store. So this brings us the end of our memory hierarchy discussion, guys. So if you have any question on this, you can ask me. I think everyone are understanding each and every concept clearly, right? And we have one more memory access. Should I show that? So now look at here. This is another memory access. You all observe here. Okay. So take one last look at the what memory hierarchy. So but this time from the what perspective of how the data actually moves. So this slide gives us a more detailed look at the what access path between the different levels of memory. So at the center of all, see what do we have here? So we have CPU. So this is our brain of the operation. So where all our computations happen. The CPU has its incredibly fast internal storage like registers, L1 cache. Correct, no? So when CPU needs data that is not present in L1 cache, then what it is going to do, guys? So it looks in the larger but still very fast cache memory. So once data is not present, so then it is going to check data in a cache memory. So this is the external cache memory we have stored here outside the CPU. So this is internal cache memory. So we can call it as L1 cache. We can call it as L2 cache. Understanding my point, guys? And once the requested data is not present in this cache, L2 cache, then it will go and check in memory directly, main memory directly. Okay. And once the data is not present, then it will go and check with input output storages. And it will go and check in secondary storage at the end. The purpose of this entire diagram is to show the layers of the access, guys. That's it. So every time a computation needs to get data from a layer further away from the CPU. So it pays a penalty in latency. The principle of locality of reference is about organizing our data and our algorithm so that we keep data as close to the what CPU as possible. So minimizing those flow, input, output, and network trips. Understanding, guys? So this brings us to the what? The entire concept of memory hierarchy. Next, we have one more diagram here. You can observe here. This is very easiest concept to understand. So here I'm trying to what explain two concepts. One is called as cache hit. Another one is called as cache miss. What do you mean by cache hit and cache miss? Can anyone tell me? So those who are familiar with COA, you have learned that concept in your COA, right? What is cache hit and what is cache miss? This is the actual mechanism that makes this all so critical, right? The concept of cache hit and also cache hit. If data is found in cache, so it is cache hit. Okay. If data is searched, okay, data searched is present in a cache miss, then it is called as cache hit. So once it is not present, then we are going to call it as cache miss. Very good answer. Okay, so what your CPU is going to do, guys, when CPU needs a piece of data, so its first attempt is always look at its fastest memory. That is your local cache. So if data finds in that cache memory miss, then it is called as cache hit. Very good answer. This is the ideal scenario because as we saw with our latency numbers, so this is incredibly fast operation. Am I right or wrong, guys? So if the data is not found in a cache miss, then what it is going to do? Then we are going to call it as cache miss. That is absolutely correct. Then what it is going to do, guys? Then what it is going to do? That I have shown you here, right? See, that I have shown you in this diagram. So once the requested data is not present, then CPU is going to search the data inside the what? Main memory. So once the requested data is not present here, then it will go to hard disk. See, this is bidirectional. This is bidirectional. This is also bidirectional. Okay, so once no data is present, it will bring data from here and it will store in main memory. It will bring data from here and it will store inside the cache memory. It will data from here, it will store inside cache or L1 cache. If it is not present, it is going to store inside the register. Okay, the entire principle of locality of reference is about maximizing cache hits and minimizing cache misses. So it is about organizing our data and our code so that when a CPU accesses one piece of data, the next piece it needs is likely to be what? Right next to it. So either in the cache memory or in the main memory. In the context of distributed system, this principle extends to the network and disk. We want to design our system to have data locality to avoid costly disk seek and network transfer. So which are equivalent of massive cache miss. Okay. Is this clear? See, next slide, I have given all the information in detail. Okay, you can go through this. So cache hit, when CPU refers to the memory and finds the data or instruction within the cache memory, is called as cache hit. Cache miss means, see, look at here. Once there is a what cache miss means, then we are going to search the data inside the what? Main memory. Then, so we are going to consider missing time, miss time, and also hit time, both we are going to consider here. Correct? No. So it will take some time to what? Check in cache memory. Once there is a miss, then it will go and access the what? Main memory. So in main memory data is present means then it is called as hit rate. So hit access time and miss access time, both are required here. And this is the formula to calculate hit ratio. So hit ratio means hit, number of hit by total number of hit plus miss. By adding these two, so we are going to calculate hit ratio and also miss ratio. So hope you all worked on this. This formula is very much familiar to you people. And we have one more formula. See, average access time of any memory system consisting of two levels. One is cache memory and main memory. If TC is the time to access cache memory and TM is the time to access main memory. Look at here. This is the time required to access cache memory. This is the time required to access main memory. Then H is the cache hit ratio. So how do you find the cache hit ratio here? See, look at here. This is the formula for T average. Average time to access memory we are calculating here. Average time to access memory is by using this formula. Hit ratio. H means hit ratio into time to what? Cache memory access plus 1 minus H means what? 1 minus H means miss ratio. Miss ratio means we have to consider both the times. Time for what? Cache memory, time for what? Main memory, both we have to consider, right? So that time multiplying here. Okay, so this is the formula we are going to use to calculate T average. Okay, this is very, very important formula, guys. So I'm going to paste this formula on your chat box because we are going to solve. See, in examination, I'm going to give you what? Problem to solve on this. Where is print screen? Yes, it is here. So better all of them note down this formula. See, this is the problem statement I've taken here. Can anyone solve this? Can anyone solve this quickly and send me the result? Guys, the core observation is simple. Programs tend to reuse data and instructions they have used recently. So this is a what fundamental behavior of most software. Correct? No? Are you getting my point, guys? So this behavior, see, you look at here, 90/10 rule. So this behavior is often encapsulated in what's known as 90/10 rule. So this is common heuristic that comes from empirical observation, which states that a program spends 90% of its time in 10% of its code. Correct? No? So the implication of this is profound. We can predict the reasonable accuracy, what instruction and data a program will use in the near future based on the recent past. So this is why caching works. Because of this behavior, we can design our system to keep the most frequently used data and instructions in the fastest memory. Okay, like the cache, knowing that they are likely to be what requested again soon. Okay, so that is the concept, guys. And look at here. So this diagram, I think you can understand this diagram by yourself. What it is explaining here, guys, just now we have talked about empirical evidence for why locality of reference works. Now let's formally define its principle. So this slide, see, that's why this slide is titled as principle of locality reference. Okay, what is the first point that I mentioned here? The locus of the data access. Okay, and hence that of memory references is a small at any point during program execution. The meaning of this is any given moment, a program is only actively working on a small subset of its data. That is the point you have to understand here. And what second point is saying, guys? So the second point is saying, so this is, see in second point, I have mentioned the definition of temporal locality. Okay, temporal locality. So look at the graph here. See, look at the graph right now. So this is, I'm talking about temporal locality. So you can see how memory address being accessed in y-axis. See, this is the addresses we have mentioned here. This cluster, a small range over a what period of cycle. Period of cycle we have mentioned in the x-axis. Are you getting my point, guys? Are you getting my point? And locality is a type of predictable behavior that occurs in computer system. That is the third point I have mentioned here. So this is the key takeaway from our last slide. This behavior is not random, so we can design for it. Okay. And what is the last point that I mentioned here? Systems that exhibit strong locality of reference are great candidates for performance optimization through the use of techniques such as the caching, prefetching, and advanced branch predictions and pipelining stage of a processor core. See, this is the what action-oriented part, because we know data access is local and predictable, and we can use techniques like caching to keep the data we need close to the processor, avoiding expensive operations. Okay, so this is one of the powerful concepts I'm teaching you guys. We apply this principle not just within a single machine's CPU, not single machine memory, but across the entire big data cluster. I'm applying this. So we design our system to bring the computations to the data and to use in-memory processing, okay, to keep data in the what fastest memory layer possible. Understanding my point, guys? So this marks the what very important concept of principle of locality. So let me check if you have any question on this. I will answer it quickly. So can you open the last slide once again? Which slide you are talking about, Joshi? You're talking about miss ratio. You're talking about T average or what, Joshi? I think T average. Okay. What do you want to know there? Yes. What do you want to know here? I have pasted that formula on your chat box, right? Do you have any question? Do you have any question on this? Joshi, the kind of problem we will have to solve. I will show you. Okay, see. So here, maybe yes, sir, this problem maybe you have solved in CO. So we are going to give you TC. So we are going to give you TM. And sometime we are going to give hit ratio. So then you have to calculate T average. This is one kind of problem you are going to get in your examination. Otherwise, sometime, so we are going to give you T average. So we are going to give you hit ratio. Then you have to calculate something else. Understanding my point, guys? So miss ratio you have to calculate by yourself. See, we are going to give you the data. The missing data you have to calculate in the examination. That's it. Okay. So you go and check in internet. You are going to get plenty of problems on locality of reference, RT average. Clear? So even in your previous year question paper, you can check. In your previous year question paper, we have given one question on this. One question on 2 marks. We have given that. You just go through that. Okay. So shall I move forward? Quickly, without wasting time, shall we move forward? Shall I proceed, guys? Yes. Okay. So now look at here, guys. This is the slide. Guys, just now we have introduced the principle of locality reference. Now let's break it down into 2 main types. So one is called as temporal locality. Another one is called as spatial locality. So I'm dividing it into 2 parts now. So let us talk about the very first one. Guys, what is temporal locality? Temporal locality is the principle that data is accessed, is likely to be what accessed again in the near future. Correct, no? In other words, data is likely to be what repeatedly accessed in a short span of time during this execution is called as temporal locality. Am I right or wrong, guys? So you think about some of these examples from this slide. Look at here. Void swap int x int y I have taken here. And t is equal to x is equal to y, and y is equal to t. Okay. See, the very first point what I mentioned here is instructions in the body of the loop. See, instructions in the body of the loop. The code for a what loop is executed over and over again, right? So CPU repeatedly accesses the same instructions. See, for example, you have put something inside for loop. For example, you have put something inside while loop. See, the inside loop, you have put some statement means. So repeatedly, you are going to visit the same instruction, or repeatedly, you are going to take the same data or variable. That is called as temporal locality. Understanding my point, guys? So inside this, so repeatedly, you are going to use t, repeatedly, you are going to use x, repeatedly, you are going to use y, right? That is one point actually. And second one, parameters are local variables of function. So this is the function we have taken. Okay, so these multiple x value is using again and again. So the parameter is also becoming our temporal locality. And data that is computed iteratively, that I already have shown you. Okay, suppose you're performing sum of the natural number or product of the natural number. So in that situation, you'll be keep on what? Iterating the same variable. That is also comes under temporal locality. And another user in Netflix in the same region will watch the what same episode. That is also the best example for what temporal locality, right? So it makes the sense to cache that content locally. And finally, a recent social media post will be what viewed soon by other users. So making it as a what prime candidate for a cache. See, look at here. These are the two case studies we have taken here. So these are the two data we have to keep in cache because these type of data are called as temporal locality. See, the entire concept of caching is built on temporal locality. Okay, so we put data that is being accessed recently into a fast cache memory because we can predict it will be what needed again soon. So thereby avoiding a what slow access to main memory, slow access to disk, slow access to remote storage. Understanding my point, guys? And what is spatial locality? So what is spatial locality, guys? Maybe you have heard about spatial locality, right? What is spatial locality? Guys, spatial locality is the principle that data accessed is likely located adjacent to the data that is to be accessed in a near future. See here, the word you have to remember here is adjacent to the data. This means that data accessed in a short span during execution is likely to be within a what small regions in a memory. What is that small regions in a memory? The best example for this is array. Okay, so look at here. Suppose you have stored data in an array. Okay, this is the data you have stored in an array. So this is A of 0, this is A of 1, 2, 3, and 4. This is 10, 20, 30, 40, and 50. Guys, initially, you are going to what visit A of 0. So next to that, what do we have, guys? Next to that, we have 1, right? See, after this, suppose you are performing summation of arrayments or multiplication of arrayments. First, you are going to visit this data. Next immediately you are going to visit this data, right? So this is called a spatial locality. Understanding? See, now you have visited A of 1. Next, which data you are going to visit next? 30 you are going to visit next. Correct? No. See, this is called as adjacent to the data that is being accessed in the near future. So this is called as spatial locality. See, here I have mentioned examples, a linear sequence of instructions. So linear sequence of instruction, one instruction, second instruction, third instruction, fourth instruction. These are all called as linear sequence of instructions, right? First, you will go with this, next. The elements of an array that already have shown you. Another user's query will reuse part of the data file for what current user's query. That is also best example for that. Means this is likely the concept of a distributed system. When we read a large file from a disk, we don't just read one byte at a time, right? So we read large block of data because we can assume that if we need one part of the data, we'll probably need the part right next to the data also. Correct? No. This is a what direct application of spatial locality. Guys, what I would like to say here is spatial and temporal locality are the twin principle that allow our big data system to be so fast. That tells us the data access is predictable and that gives us the green light to use caching. It is going to give a what green light to what prefetching. Other techniques to keep the data we need to close to the what computation as possible, avoiding these costly trips across the what network. So hope everyone understood what exactly mean by temporal locality and also spatial locality. If you have any question on this, quickly ask me, guys. I will go through that. So otherwise, I will move to the next point. Just now we have explored the concept of principle of what locality. Okay, now let's tie them directly back to the what concept of the memory hierarchy. Okay, so now I'm tying this concept to the memory hierarchy concept in the next slide. Guys, the first point on this slide is crucial takeaway. A memory hierarchy is effective only due to locality exhibited by programs. So the entire system of having a fast, small cache and slow, large main memory only works because program tends to access data with temporal and spatial locality. If data access was completely random, a cache would be useless. That you should understand. And the second point, what I mentioned here, longer the range of execution time of the program, larger is the locus of the data access. So this simply means that program's overall data footprint grows over time. So which is why we need a large, slow memory for long-term storage. So even as we use fast, small cache for short-term access. And this leads to the what final and most important point. So that is, see, the need to have cache replacement strategies because increasing cache size will also increase access time and increase cost. Of course, yes, right? So because a cache is small and expensive, okay, we cannot just keep adding data to it forever. So when the cache is full, so we need a strategy to decide which old data to throw out to make room for what new data. Okay, so for that we are going to use the algorithm LRU. So least recently used algorithm or strategy we are going to use when your cache size is full. Okay, so this is simple but effective strategy that directly leverages temporal locality. The idea is that if a piece of data has been used recently, it is less likely to be used in the near future. So when a cache is full, we remove the data that was least recently used to make space for the new data. Very simple. So this conclude deep dive into fundamental concept or fundamental principle of big data. Okay. So hope everyone understood how we are going to use it in big data concept. And next slide you can observe here. So what I'm trying to explaining you here, see, look at here. LOR leads to memory hierarchy at two main interface level. What are those two levels? First, there is a what interface between processor and main memory. Okay, so this is where we see the introduction of cache memory, correct? No? Okay, the unit of data transfer here is not a single byte, but a block of data we are transforming here. Okay, that block of data is called as number of cache lines. So this is a what direct application of spatial locality. When the CPU needs one piece of data, it fetches the whole block because it likely the next piece of the data will be what nearby. And the second interface is between main memory and secondary storage. So what we have introduced there, we have introduced virtual memory concept, that is paging concept. So these two concepts you can learn in operating system. So this is where the concept like virtual memory and paging systems comes into play. The unit of data transfer here is page. So which is typically of 4 to 8 kilobytes. And guys, you have to understand all these concepts, guys. So better you all go with what operating system videos to understand this cache concept and also for this paging concept. This is very, very important. And the next slide, see, I'm giving you more information on LOR. Guys, in Java, we have two common list implementation. So one is called as linked list, another one is called as array list. So the question is, so which is better data structure to use for sequential access performance? What is your answer? What is your answers, guys? Which one is better? Is this a linked list or array list? Huh? Okay, so many of my friends are saying array list. So let me take one scenario here. Okay, let me take one scenario here. Okay, so this is the test scenario I've taken for you people. So if we append a single element in a loop n times to both linked list and repeat with array list. Okay, the time complexity of that operation is theoretically the same for both the collections. What is the time complexity it is going to take? So it is going to take 100 runs. Okay, now tell me which one work faster. Now tell me guys, which one work faster? Still array list? I'm getting mixture of answer. Is this array list or linked list, guys? Okay, now answers are changed. Guys, the answer is that question is array list will work faster. And the reason for this is locality of reference, guys. See, just now I've explained you about locality of reference. And also I've explained you about spatial locality. So which concept is containing spatial locality? Array list or linked list? See, an array list stores its elements in a what contiguous block of memory. When you access element of I, the processor fetch that data and also prefetches the data right next to it into the what cache memory. Because it is good, but you will need what elements of what I plus 1 next. This results in a what cache hits, so which are incredibly fast. Correct? No. So once I'm taking linked list concept. So once I'm taking linked list concept, however, stores its elements as nodes scattered throughout the memory. Correct? No. To access the next element, the processor has to go to that completely different memory location. This leads to what? Cache misses. So which are very slow and negate the what theoretical time complexity advantage. So this is the what perfect example of how this low level principle directly impact the performance of the code you write every day. So knowing the principle of spatial and temporal locality is what allow us to write performant code. And it is what makes the entire big data ecosystem possible. Okay. So now guys, I would like to ask you one question for each and everyone. So who has to become efficient programmer? Who has to become efficient programmers, guys? Efficient developer or programmer? No one has to become efficient programmer. Jyoti is raising her hand. What about others? Only Jyoti? Then what you need to do, Jyoti? So what you need to do? Aditya is also raising his hand. So then you people have to write a what cache friendly code, correct? No. So once you people are writing cache friendly code, then you people will become efficient programmer. So instead of becoming programmer, you have to become an efficient programmer, guys. To do this, you have to what? Write cache friendly code. So how many of them will agree with this point? How many of them will agree with this point, guys? Okay. So now look at here. This is the graph. Performance bottleneck, a benchmark of append operations. Array list and also linked list, both we have mentioned here. See, by looking this, at least now you can tell me, guys. So which is better one? Understanding? So here we have mentioned number of elements in x-axis. Okay. And linked list we have mentioned in brown color one. And array list we have mentioned in blue list. So all the values are mentioned in milliseconds. Okay. All the values are mentioned in milliseconds. Correct? No. The analysis confirm our hypothesis. Sequential access in array is faster than on linked list on many machines, because They have a very good spatial locality of reference and thus makes good use of data caching. That is the reason. So this is powerful real world demonstration of how these foundational principles of computer science directly impact your day-to-day work as a developer. Understanding spatial locality and how caches work is what allow you to write code that performs efficiently. So even for simple operations, correct? No? Yes or no, guys? So this is the example I've taken here. This is the example I've taken here. Okay, so here I mentioned row major and also column major. Two different programs I've taken here. See, look at here. I is equal to 0, I less than n, I plus plus I've taken here. J is equal to 0, j less than n, j plus plus. So M3, this is matrix. Matrix of I comma j is equal to M2 of ij plus M1 of ij we have taken here. So two different matrix we have taken and we are performing addition operation. So here we have used row major methodology. So here we have used column major methodology. Okay. So both options have same time complexity, but why one is faster? So that is the question I'm asking to you all. So to understand that, so this you have to understand, guys. See, initially in row major. So in row major, so you are going to take the very first word. See, first time you are going to visit this memory location. I is equal to 0, j is equal to 0. So on that situation, nothing is stored inside the cache memory, right? So then it is called as cache miss. See, the entire row is stored here. So next onwards, W1 is already present, cache it. W2 is also already present, cache it. W3 is already present. So this is called as cache it. Because you have transformed a block of data. And same with respect to I1 also. Same with respect to I2, I3. See how many number of cache miss we have here? Only 4 number of cache miss we have. So remaining all cache hits. So once we have more number of cache hit, then I can say this is the best system. But in case of column major, see, first you are going to copy this. Correct? Now column major, W of 0 is copied, W of 4 is copied, W of 8 is copied, W of 12 is copied. So next again, you are going to copy this column. Next this column, next this column. See, in column measure, number of misses are more. Number of hits are equals to 0. So that's why which one is best, guys? Which methodology is best? After understanding this, which methodology is best? Can anyone tell me? Row major will be always best, right? Are you understanding? See, this is the example I've taken to what explain you guys. This is what you have to understand at the time of what writing your cache friendly code. Clear? Okay. Guys, we have explained simple change in code can impact performance. Now let's look at how the same principle, spatial locality, drives the fundamental design decisions in many big data systems or in many storage organizations. So that's why I have mentioned this slide as big data storage organizations matters. Okay, so it provides a greater example, guys. You just go through this example. Let's say we need to build a prediction model for sales, and the key metrics we are focused on is total sale. So we are focusing on total sales. Okay, so in traditional row-based databases, a record for a sale would contain many attributes, but our query only needs total sales. Remember this. So the solution presented here is columnar storage. So instead of taking what's row major, so we have taken columnar storage. So instead of storing data row by row, we store it column by column. So this slide explains that if the database is columnar or column major data organization, It will fetch block of total sales column and not the other necessary columns. Correct, no? So this directly leverages spatial locality. Okay, our query only needs to read a small contiguous portions of data on the disk. By fetching only the required column data in a single block, we exhibit high spatial locality and get much better hit rate. Okay, the final point on this slide is majorly what takeaway. Columnar storage is common in most big data system to run analysis, queries, and focus on specific attributes at a time. So this is the reason why many analytical databases like your Vertica, so even projects like Apache Parquet are built on this principle. Okay, so this brings us to the conclusion of our fundamental session, guys. So this is the summary I have given. I don't want to go with the summary. So this will complete your entire first session concept. So hope this concept is crystal clear to everyone. Guys, actually first class we had 88 number of slides. So that's why it has taken 3 sessions to complete the syllabus. In first session, I've not covered anything from the slide session 1. So second session and third session, I'm completely dedicated to the session 1 concept. So next class onwards, guys, I will try to extend half an hour class and I will try to complete the syllabus and I will try to take 1 extra class to complete the syllabus. So is it okay for you all, guys? Is it okay for you all? So next week I will take half an hour extra. Okay, another next week I will take half an hour extra. So and one day I will take extra class to complete the syllabus. So is it okay for you all? Guys, once you are good at fundamental, then understanding remaining concept is very easy. So that's why first session I've spent lots and lot of time to complete the syllabus. I think now you people have solid, comprehensive foundation for what big data is and how these systems are designed to overcome the challenges of data-centric world. Yes or no, guys? So how many of them are going to say yes? How many of them are going to say no? Okay, now the time is for your question and answer, guys. So if you have any questions, so regarding today's session, you can ask me. So I will answer to your questions. Later on, I will show you guys, this is the content we have in second session. So we are going to focus on parallel and distributed processing in the next coming class. I just show you once again. Where is the second session slide? So this is the second session concept. So we are going to explain completely on parallel processing. Okay, we have Amdahl's law. So we have so still I'm taking few concepts from your computer organization to understand it better. Okay, so Flint's taxonomy we are taking here, distributed concept, sequential concept, everything we are explaining in the next coming class. So any doubts on today's session? So we are left with 6 more minutes. So how you felt in today's session, guys? So can you give me 1-line feedback on today's session? What about my pace of teaching? Am I giving sufficient information to understand each and every slide? So instead of giving one word or two-word answer, please give me one big sentence about your understanding. Yes, exactly. Yeah, of course, yes. You have to learn all 8 session concept for your EC2. Bit technical term, need to go through the again, but the session was good. Okay. So Rahul, please go through the fundamental concept. Without understanding all these fundamental, it is very difficult to understand next coming classes. Okay. So we have taken all the concepts from COA background, COA textbook. Okay, computer organization and architecture textbook. And even next class also, I'm going to give you more information on distributed computing. So there also we are covering few concepts from COA. Okay, Rahul, you have to go through it. Yeah, I will share. Not an issue. I will share next session slides for you people. Without annotation is okay for you people. Okay, I will share both, guys. So without annotation, I will share you in the what session 2. Okay, with annotation, you will get in the next class. So textbook, you better go with the textbook what we have mentioned in the handouts. Or you consider my slides as a what textbook. It is more enough. Why next Sunday? What is the problem? Why you people are asking this? So let me check in my calendar. Oh, it is scheduled, right? See, it is scheduled. Why you are asking this question? Anything special on next week? So convocation, I guess, sir. So whatever it is, see for convocation for final year students, right? Huh? I am not going there actually. Because of your class, I am not going there. Gautam, actually slides are more enough, but I have told you, right? So we are going to ask case study based questions in your examination. See, just now I've given one example on Netflix, right? So that type of what case study you are going to get in the examination, and on what T average, you're going to get one problems. Okay, so it is a mixture of what both. Sometime I'm going to give you scenario, sometime I'm going to give you case study kind of questions, and sometime I'm going to give you numerical problems. Okay, so all three I've covered in today's session. So that you have to follow. Rahul, sorry, I am not canceling next week class because I am not attending convocation. Sir, can you suggest what should be the strategy to study this subject? Lecture revision and PPT is enough or anything else is needed? This is enough. Otherwise, you go through some YouTube videos. So that will also give you what more knowledge on big data system. Joshi. Or else my explanation is more enough. You keep on what repeatedly go through my recording. That is more enough. See, guys, actually, before I'm taking your class, I am taking, see, this is my job. I'm taking what so many resources and I'm studying everything from what different resources and then I'm coming to the class. So simply I'm not going with the what slides, correct? No, you're all understanding. So every time you have seen, right, one example, one real-time example I'm taking on each and every concept. Am I right or wrong, guys? Then my explanation is more enough according to me. Suppose you need more means, then you go with what other resources, not an issue. That will always give you good knowledge. Continuous learning is always better, correct? No? Guys, actually speaking, you people are all are working on what industry, right? So in industry, you have to change your job means you need more knowledge. So better you go with other resources also. So that is very much beneficial for you people. So anything else? No one is asking questions on today's session. I think I have clarified each and every concept. So that's why I'm not getting any questions on today's session. Am I right, guys? Okay, thank you, Archana. Okay, guys, then no questions means please give me one line feedback on today's session. And if anything I want to what improvements, please put it in the what message, guys. So I will try to what update. I will come with the what updation in the next class. Okay, I will post both the slides on your Tuxila. Okay. So in Tuxila, have you seen in Tuxila, I have uploaded all the slides. So even I have put a what message. So annotated slides, I'm going to update in the Tuxila. So next coming class, session 2 slides also, I'm going to upload in the Tuxila. Please in Teams files. Yeah, in Teams also I'm uploading, Gautam. So have you checked? In Teams, see, after completion of my class, immediately I'm going to upload it in Teams. You go and check there. Okay, guys, no questions means we can wind up today's session. So thank you all for attending today's session. A big thank you for all your attention today. And I look forward to seeing you in our next session. So where we will begin to explore some of these technologies in more detail. So have a nice day, guys. Bye-bye. See you. We will meet you in the next session. Thank you all, guys.